Welcome to Efiwe, excellence without stress.
Hi guys, we're back again, and today our topic is vapor. Starts by defining evaporation. What is evaporation? Evaporation is a process where a liquid turns spontaneously into vapor below its boiling point, and it takes place at all temperatures. That's evaporation. When water or any other liquid is exposed in an open dish, it slowly evaporates. That is, it goes spontaneously into the gaseous state. It goes spontaneously into the gaseous state. The best explanation for this is when you boil water and you leave it on the gas for a very long period of time, you notice that the water will start decreasing. What has happened was the water has evaporated. So evaporation is a process where a liquid turns spontaneously into vapor below its boiling point. It takes place at all temperatures. That's evaporation. Factors affecting the rate of temperature of evaporation. The first one is temperature. We know that the rate of evaporation increases with increasing temperature. That one is a known fact. It increases with what? Increasing temperature. The other one is pressure. The greater the pressure, the slower the evaporation, and vice versa. Wind and dryness of the air. The drier the air, that is, the less water vapor it contains, the faster the evaporation. Wet clothes dry faster in dry air. So these are the factors affecting the rate of evaporation. Also, the nature of the liquid. Liquid with low boiling point evaporates more rapidly. You know why? Because after the water has boiled, that it will now get to the stage of evaporation. So liquid with low boiling point evaporates more rapidly than those with high boiling point. Hence, ether with boiling point 35 degrees Celsius evaporates more rapidly than mercury with 357 degrees Celsius of boiling point. Also, the area of liquid exposed. The greater the surface area of liquid exposed, the faster the evaporation. So then we're going to boiling point. Boiling point of a liquid. As we heat water in a container, its temperature rises and the liquid evaporates. As the heating is continued, the temperature is found to rise until the water begins to boil. During boiling, bubbles of air formed inside the liquid and rises to the surface. I'm sure we know all of these. If we have seen the water boiling before, we notice bubbles at the surface, and it will be at the surface of the liquid. The temperature of the liquid remains steady during boiling point. You know, water boils at 100 degrees Celsius. This constant temperature is called the boiling point of the liquid. Differences between evaporation and boiling. Evaporation, this is a change from liquid to vapor at temperature below the normal boiling point. This is the change from liquid to vapor or gas at temperatures below the normal boiling point. While boiling, this is a change from liquid to vapor at the boiling point. Evaporation is below the normal boiling point, while boiling is at the boiling point. Another difference between the two of them is it takes place slowly at the liquid surface. Evaporation takes place slowly at the liquid surface, while boiling occurs throughout the entire volume of the liquid. You will experience the boiling throughout the entire volume of the liquid. Evaporation takes place at all temperature, while boiling takes place at a particular temperature for a given pressure. Temperature need not to be steady during evaporation, while for boiling, temperature remains steady during boiling. Evaporation. Wind assists evaporation. Wind has no effect on boiling. These are the difference between evaporation and boiling. Relative humidity. There is always some water vapor present in the atmosphere. This is due to evaporation from oceans, from rivers, and from lakes, etc. So there is always some water vapor present in the atmosphere. And why? This is due to the evaporation from oceans, rivers, lakes, etc. The water vapor content of the atmosphere is known as its humidity. The water vapor content of the atmosphere is known as its humidity. If there is a high percentage of water in the air, we say that the air is very humid. So relative humidity is a term to describe how humid or moist the air is. That's relative humidity. Relative humidity is a term to describe how humid or moist the air is. Relative humidity is the ratio of the mass of water vapor present in a certain volume of air to the mass of water vapor required to saturate the same volume of air at the same temperature. That is relative humidity. Relative humidity is the ratio of the mass of water vapor present in a certain volume of air to the mass of water vapor required to saturate the same volume of air at the same temperature. So relative humidity is usually expressed in percentage. A relative humidity of 100% means that the air is completely saturated with water vapor. A relative humidity of 100% means that the air is completely saturated with water vapor, while a relative humidity of 50% means that the air is only half saturated. Relative humidity values are used by meteorologists in weather forecasts. Effect on humidity on personal comfort. Air conditioning. Very high humidities or very low ones make us feel uncomfortable. In a hot and humid weather, as we usually experience during the rainy season, the body sweats but cannot dispose of the moisture. The skin therefore feels damp and unpleasant. Some people may experience some difficulty in breathing. A good air conditioning system helps to maintain the correct humidity and temperature in a building. In a hot and humid room, the air conditioning system both cools and removes the moisture from the room. Dew point. Water vapor is always present in the atmosphere, as we have established. If a sample of air is cooled, a temperature will be reached when the air becomes saturated with the water vapor present. This temperature is known as the dew point, and any further cooling will cause the excess water vapor to condense into tiny visible droplets called dew. Water vapor is always present in the atmosphere. If a sample of air is cooled, a temperature will be reached when the air becomes saturated with water vapor. This temperature is then known as the dew point. So what is dew point? Dew point is the temperature at which the water vapor present in the air is just sufficient to saturate it. Dew point is that temperature at which the water vapor present in air is just sufficient to saturate it. Another way of defining relative humidity is therefore related to dew point by relative humidity is equals to saturated vapor pressure at the dew point divided by the SVP at the air temperature. Mist and fog. When moist air near the surface of the land cools until it reaches dew point, water vapor originally present in the air begins to condense around tiny suspended dust particles in the air. They form suspended water droplets in the atmosphere. A collection of these suspended water droplets constitutes a mist. Mist reduces visibility. You can see the way it looks, especially during harmattan. That's why we notice mist. Mist reduces visibility. In severe mist situation, we have a fog. Under foggy situation, motorists have to drive slowly, and visibility can be so reduced that it becomes necessary to drive with the vehicle headlamp switched on even in the day. I'm sure we've experienced this sometimes. Then we have the clouds and rain. A thick mist, when formed high up in the atmosphere, is known as a cloud. As warm, moist air rises over the land or sea during the day, it becomes cooler as it moves higher and higher in the atmosphere. If this cooling process continues long enough, the air may become saturated, causing the water vapor to condense as tiny water droplets. A combination of several such water droplets constitutes a cloud. A combination of several such water droplets constitutes a cloud. You can see it from the picture here. Instability in the condition of the cloud may cause rain to fall. Certain types of cloud, known as cirrus cloud, form at very great heights. They are composed of ice crystals due to the very low temperature prevalent at such heights. Measurement of relative humidity, the hygrometer. This is what we use to measure relative humidity. An instrument known as hygrometer is used to measure the relative humidity of air. A simple and common form of the hygrometer is the wet and dry bulb hygrometer. It consists of two thermometers, the wet bulb and the dry bulb. Thermometers mounted side by side. The wet bulb thermometer has its bulb covered with a piece of moist cloth, and the lower end of which dips into small water pot containing some water. So this is the measurement of relative humidity, and we use the hygrometer to measure relative humidity. So that's all for today's class. See you in the next class. Thanks.